So good morning, good to be here. Second year running, the coolest VC event in Europe. Since 2017, we're a Swiss company. We've developed a stack microstructure. It's a platform technology that can be used in low temperature fuel cells, high temperature fuel cells, and electrolyzers. But original DNA was in fuel cells, so we thought, well, where do these things belong? In things that are extremely heavy, aviation, marine, and large stationary power. But for 20 years, fuel cells and stacks really as a whole have by and large kind of only had incremental improvements. If you open one from 20 years ago and you open one now, it kind of looks more or less the same. Some sort of bipolar plate, gas diffusion, yada, yada. Ours looks completely different. And that gives us several major advantages. The first is that our stacks are basically half the size and 2/3 of the weight of the next best thing. In addition, we can make much higher powered stacks. So for things that matter, things that fly, big boats, etc., you start off with a much larger building block, typically 3 to 4 times larger than what can be done with conventional technology. Furthermore, when we go to the system, so you have what's called the stack, and then you have a system around it, we are able to gain significant efficiency gains by reducing the parasitic loads of the balance of plant. So that means in marine, we get 3 to 4% extra in efficiency, and in marine, as well as in trucking and so on, every percentage point is crucial. And finally, this is designed for manufacturing, because the cost of stacks is not about materials like it is in batteries. It's about processes. And typically the process involves multiple partners and different machines, and it goes back and forth. In our case, we started working 4 years ago on a roll-to-roll machinery. We get basically your raw materials one end, it spits out a completely assembled stack in 20 minutes. And the key here is that you can scale up very quickly, but crucially, even at relatively low volumes, you're able to cut costs radically. So this is all patented. We're going through the whole internationalization phase. So 20 of the 50 are already granted, and it just takes a certain amount of time. Not everything we put as patents. A lot, to be honest, we just keep as in-house trade secrets. The today market is actually stationary, because to a certain extent you overcome the limitations of the lack of hydrogen refueling, etc. But we see very strong demand for large containers, either from clients who make the containers with a battery, etc., for EV superchargers, cold ironing at ports, microgrids in particular, or in some cases at the moment we have to use subcontractors to make the containers for us, but that's not really our core business. In mobility, we started deploying them in 2020, and things have only got bigger and bigger. So our largest clients are in the mining sector, where the target is to decarbonize those trucks. That's 2 megawatts of power per truck, so that's 20 cars equivalent, running on about 1.2 tons of hydrogen per day is the goal. And marine, where IMO regulations are very much pushing things forward and where we see strong traction. And finally, aviation. I know everyone's like, oh, it's 5 to 10 years away. 5 to 10 years in aviation is like tomorrow. And all the big players, Safran, Airbus, the rest, are pushing very, very hard on this. So these are really the 3 markets which we see sequential and which we're targeting, and all fit on our core product. So if we break it down into sort of where the markets are right today, we see literally 60% of our client inquiries by value and power are in stationary. At the moment, we are struggling to meet demand. Similarly, in maritime, it's a smaller number of projects, but much higher value by the virtue of the fact that boats need larger power. It's still a long sales cycle because most people have never bought one before. What safety, what hydrogen purity, etc. But once they get the grasp of it, all of a sudden lead times become super important, and that's what we need to scale up. There's about nearly 30 of us. Myself and the executive assistant are about the only non-engineers, and it really is, electrochemists, mechanical, electrical, everyone is required to work in union to make this happen, which is why it's so challenging. Where we make our money is on stacks. 50 to 60% gross margin on our stacks, even now at relatively low volumes, at 30-40% at the system level on sort of larger systems of, say, 250 kilowatts. we're not that CapEx heavy because we've been able to design that production machinery ourselves. If we went into the market to try and sort of buy an MEA machine, that's calling like 10 million euros just for the MEA module alone, and we've basically completed the whole thing with less than 5 million euros. So we're currently raising some more capital. We've raised about 17 million so far. We're looking for another 20 million to scale up our activities. And really the bulk of this is to grow the team. At 30, we're extremely stretched. At 50, we'll probably be extremely stretched as well, but we need to get there. A bit of CapEx to complete the production machinery and complete the production facilities. So the goal is eventually to migrate towards just stack production, but in the interim, the client needs a full, complete solution. So our fuel cell system, which has now been approved for marine and stationary use, will be getting deployed to customers in September onwards for the largest power. And the final question is, why now? Because everyone's seen the Gartner hype cycle, and everyone typically gets caught on the wrong side of that. So this is the time. Of course, it's a big challenge. This is real engineering. It's a bumpy road. But if you have defining and differentiating core technology and a strong team, which we believe we have, then I think you have something to offer. Thank you very much.